What up, calculus students? Mr. Messer here. I'm going to try to breeze through all the A-B free response questions from the 2023 year in 15 minutes, okay? Instead of the hour-long live reaction video, short 15-minute video, so I got until 12:30. Let's go. Question number one, we got a customer at a gas station. He's pumping gas into a tank. It is the rate at which gas is being added, okay? Now, this is a differentiable function f, which means you can take the derivative. And this happens to be a derivative. So what I like to do with these problems immediately, these rate in, rate out problems, is immediately understand what we got. You know, is it f? Is it f prime? Is it f double prime? Is it a position? It's a velocity. It's an acceleration. I know this is confusing, which is why this is going to go away. And I'm just going to immediately say f is in gallons per second. F starts right here. F is a velocity. This is kind of a little bit of a curveball from the test to have the function f be defined as a derivative. That means f prime is going to be an acceleration. It'll be gallons per second squared. And the antiderivative, or the accumulation of f, if I go the other way, will be a position. Okay? So keeping that in mind, let's go through question number one. Part A asks to interpret the meaning from 60 to 135 of f. So immediately I'm like, oh, okay, I'm taking an antiderivative of f. I'm going to get a position because f is a derivative. They try to trick you with that. Make sure you didn't get tricked, hopefully. Hopefully you didn't get tricked. They're hooking you up by telling you 60 to 90, 90 to 120, 120 to 135, saying you only need three rectangles, three right rectangles. So we find our three rectangles and their areas. We got a 30 by 0.15, we have a 30 by 0.1, and a 15 by 0.5. So there's that. I'm going to write this down just to make sure I know I'm approximating an area. This is areas. I get 8.25 if I did this by using my calculator. And this is total gallons, right? This is an accumulation of a derivative. This will be a displacement. This would be total gallons of fuel added. All right, I think this is going to be worth 3 points. I think this is going to be 1 point to show you have the right Riemann sum. So if you used a couple extra values, maybe you went all the way from 0 to 150, and you had more than 8.25, you included a 60 by 0.1. They'd still give you a point if you knew how to take a right Riemann sum. I think if you used all of the correct values, you get the value, that is worth a point. And then units of fuel added, or the total gallons flowed, that'd be 1 point. So 3 points total. Part B, must there be a value C such that C between 60 and 120, such that a derivative equals 0? So this is a classic mean value theorem problem. If you look between 60 and 120, and you look at the values, you see like there's no change in the values. So the mean value theorem states that if your function is differentiable, the average rate of change and an instantaneous rate, so you find your average rate of change over an interval, the instantaneous rate of change must equal that average rate of change somewhere. Okay, so all they want you to do is probably say mean value theorem somewhere, say that the function is differentiable, which means the mean value theorem can be applied. You're continuous and smoothly connected, no sharp points. They probably want you to find the average rate of change by doing the y2 minus the y1 over x2 minus x1. You get the average rate of change is 0. Therefore, there must be a derivative of c that equals 0 by the mean value theorem. Now, I was thinking there was going to be another way that they would accept this answer. And the other way would be trying to use the intermediate value theorem. And the idea being, if between 60 and 90, your f is increasing, and between 90 and 120, your f is decreasing, f prime's got to be positive, and then f prime's got to be negative. That means f prime's got to equal 0 somewhere. However, this is not going to work, unfortunately, because we know f is differentiable. F being differentiable does not mean f prime is continuous. So we can't assume f prime is continuous. So this probably will not be accepted, though it kind of makes sense. The way we've been able to kind of use it in the past is if they said that f is a twice differentiable function, which means f is differentiable and f prime is differentiable. And if f prime is differentiable, that means f prime is continuous. If f prime was continuous, then we could say this. But we can't assume it, so mean value theorem is the way to go for part B. I think this is worth 2 points. I think 1 point for finding the average rate of change, 1 point for stating the function is differentiable. You can use the mean value theorem. So 2 points total, we're at 5. Part C, G can model the stuff you see here in F. Okay, G is an equation that can also model the rate that gas is flowing. Find the average rate of flow of gasoline. Average G, 1 over B minus A, integral from A to B. Use your calculator. You can find your integral from A to B. Make sure you type it in correctly. It was a little bit tricky. Divide that by 150, you get 0.095. This would be in gallons per second because it's an average G. I think this is worth 2 points. I think 1 point for an integral, 1 point for the answer. So we're at 7. And then G prime of 140. I go ahead in my calculator and I take the derivative of G. Now, very important to go back to understanding that G is a rate. So G is a velocity. G's derivative is going to be an acceleration, just like F's derivative would have been an acceleration. So we got the value, negative 0.0049. You could 0.004 or 0.005. Interpret the meaning of your answer. It is in gallons per second squared. It's an acceleration. Don't say acceleration, though, because we're not talking about motion. Just say it is the rate of change of G. It's the rate of change of the rate that gas is flowing. Or you could say the rate that gas is flowing is decreasing by 0.004 gallons per second. I think this is worth 2 points as well. I think 1 point for the value, 1 point for the answer and the interpretation. So there we go. We get to 9 points. How did you do? Don't think I'm getting this done in 15 minutes, but let's go. Steven swims, 50-meter long pool, 90 seconds. I have a velocity. I'm immediately going to graph velocity. I'm immediately finding the zero velocity. I immediately do a sign analysis, and I'm going to do a displacement analysis. Just for my knowledge, okay, the dude starts somewhere, probably at a position of 0, but they didn't say that. But it makes sense that he starts at a position of 0 because he goes to the right 49.921 meters, which means he goes across the pool, probably touches the pool with his hand or his foot or something like that, and then he starts swimming back. So he's like, 3/4 of the way coming back on the pool from 56 to 90. All right? Cool. Part A, find the times in which Steve changes directions. Okay, I found that. 56, when velocity changes sign. That's your reason for your answer. T equals 56 because V changes sign. When V changes sign, position will change from increasing to decreasing. We change direction. But you just say V changes sign. This is probably worth 1 point, maybe 2. Part B, at 60, find the acceleration. Is Steven speeding up or slowing down? So I have the graph of V. I go ahead and take the derivative, and I find the acceleration. V prime of 60 is all I need to show for the setup for my calculations. I get negative 0.036, and this is in meters per second squared. Indicate units, okay, meters per second squared. Again, it's an acceleration. Speeding up or slowing down. I see that my velocity value is negative, and my acceleration value is negative. Since my velocity and acceleration have the same size, speed's increasing. Velocity is negative and decreasing, boom. This is probably worth 2 points. You're probably getting 1 point for the acceleration, 1 point for speed increasing based on the signs of V and A. So what are we at now? We're at 4 points so far. Find the distance. Okay, this is tricky the way it was worded. It says find the distance between Steven's position at time t equals 20 and his position at time t equals 80. Show the setup for your calculations. It's not asking you for the total distance traveled. I'm going to go ahead and adjust my sign analysis. Here's my adjusted sign analysis between 20 and 80. My velocity is positive from 20 to 56 and negative from 56 to 80. I'm going to adjust my displacement analysis. I go to the right, 31.332, but then I come back to the left, 7.948. They're asking you for the displacement or the change in your position. You don't know where he is at time 20. Well, you could say it's some C value. Well, this would be C plus 31.332. This is C plus 31.332 minus 7.948. You actually just had to find the displacement. Either plugging this into your calculator, the 20 to 80. This is me doing the displacements. Either 20 to 80 or splitting it up into 20 to 56, which is that 31.332, and the 56 to 80, adding those two numbers together, right this much, left that much, or getting this number by plugging in 20 to 80 of V. I think that's worth probably 2 points, one for using an integral and one for finding the value. So we're at 246. Last one's got to be worth 2 or 3. One of these questions is worth 3. I don't know which one. I bet you this previous one, part B, is worth 3. Don't ask me why or how. Because D is not that crazy. Distance from 0 to 90. Okay, well, if you did your sign analysis and your displacement analysis, you go to the right 49.921, you go to the left 12.242. You can take this positive number, subtract the negative number, or you can use an absolute value to get the same accumulation of your speeds, 62.164 meters. This is worth 2 points, maybe 3. Don't think this was a hard question, okay? All right, question number 3 is our differential equation. We got dm dt, part A. We're asked to sketch a solution curve through 0, 5. The key thing I think they wanted you to pay attention to is that the m values have to be less than 40, which is why they're probably wanting you to just sketch the bottom, or they definitely want you to just sketch the bottom half of your solution. So this is my solution for m, where we are below 40. They don't want this as well. If you provided that as well, they're probably not giving you the 1 point for this solution. M's got to be less than 40, so that's worth 1. Part B, use the line tangent. Well, we got the point 0.05. We find the slope by plugging in 5 into dm dt. We start with our equation y minus y1 equals m times x minus x1, but I'm using m's and t's. I then plug in 2 and do this, leave the calculations like that, you get the points. This is probably worth 2 points. 1 for the equation, 1 for the approximation. Maybe it's worth 3, where you got slope, equation, and then approximation. Write an expression for the second derivative. A lot of people are making mistakes on this. Why are you making mistakes on this? Well, you got to take the derivative of your first derivative. But look, we got dm over dt. To get d squared m over dt squared, you're not taking the derivative with respect to m. You're taking the derivative with respect to t. It's kind of like ddxing things. Now, to do this derivative, I'm going to distribute the 1/4, then ddt. Most people are not catching this thing. This has happened before. You've been ready for it before, or you've forgotten about it. The derivative is negative 1/4 dm dt. This has happened on a previous free response question multiple times. And everybody gets it wrong. So, I don't know, hopefully you picked up on it, but you can get partial credit. You probably get 1 point for the correct second derivative. But then based on your sign of your second derivative, you can then get the second point. Now, I know that since m is less than 40, the second derivative has to be negative. If the second derivative is negative, I know we have a curve that's concave down, and a tangent line would produce over approximations. Most of you are probably saying that your second derivative, d squared m over dt squared, is just negative 1/4. You are probably saying the second derivative is negative, and then you're probably saying under approximation, you're going to get a point for that. So at least you're coming away with 1 point, but maybe not the 2. All right, and then we get to part D, which is probably a 4 or a 5 pointer. Let's see, we had 1 here, 2, 3. I say 4, 5 here. So this is probably worth 4 points, and I'm not surprised because it's an intense solution to a differential equation where we start by separating our variables. They say use separation of variables. It was very nice of them for saying that. We then take the antiderivative of both sides. Most people are going to mess up right here, where the antiderivative is log 40 minus m, but you got to undo the derivative of the inside. You need a negative in front. The antiderivative of 1/4 t plus c, you're probably getting that right. I'm going to take the opposite of both sides, move the negative over. I'm going to take e to the power of both sides, and this becomes e to the negative 1/4 t plus c. Use exponent rules to write it as times e to the c. Move that c to just be c e to the negative 1/4 t. You get rid of the absolute value, making the c a plus or minus. But when you use the initial condition 0, 5, you will get the correct positive or negative c. I get c as positive 35 because e to the 0 is 1. So since c is 35, here's my equation, 40 minus m equals 35 e to the negative 1/4 t. I then solve for m, subtract 40, multiply by negative 1, we get that. This is probably 4 points where you separate your variables, that's worth 1. Your antiderivatives are worth 1. Finding c, solving for m, variations of that give you the 4 points. Maybe you drop a point here or there because of your antiderivatives, but you could still get 3 out of 4 fairly easily. Maybe this is going to be more like 30 minutes. All right, question number 4 is your very standard. This is the graph of f prime. Okay, what am I doing first before anything? I'm just paying attention to the data given. F of 2 is 1. This is the graph of f prime. I can see I can find some areas. I'm immediately doing a sign analysis. Boom. F prime, positive, negative, positive, positive. F is increasing, decreasing, increasing, increasing. I'm going to find the areas where this is a tricky area found. This is we're trying to find this area underneath the graph. A lot of people mess up on that. That means I need the rectangle and subtract the quarter circle with a radius of 2. You get 4 minus pi. If you didn't know how to do that, there was ways around it, which I'll show you. We know f of 2 is 1. We'll be able to work backwards. Since I displace 3 downwards to get to 1, we know we come from 4. Since I add 1 to get to 4, we start at 3. So 3 to 4 to 1 to 7 minus pi to 11 minus 2 pi. Part A, do we have a max min or neither at 6? Through our sign analysis, we see that since f prime does not change sign, we don't have a min. A lot of people will say, oh, there's a min right there. But no, this is the graph of f prime. The question's about f. Okay, f has a neither. F prime does not change signs. Didn't write that down. This is probably worth 1 or 2 points. So a neither, and then f prime does not change signs. Does not change signs. Write that out. Maybe that's worth 1 point, maybe worth 2. Part B, when is f concave down? This is when I do my second derivative sign analysis. I see f prime decreases, increases, decreases, increases, or the slopes of f prime are negative, positive, negative, positive. Negative 2 to 0, 4 to 6, negative 2 to 0, 4 to 6. F double prime is negative. The slopes of f prime are negative. F prime decreases. All ways to get your answers. You're probably looking at 2 points, 1 point for the intervals, 1 point for your reasoning. Part C. Yo, I hope you were ready for L'Hopital's rule, because here it is, just like in your practice tests. What did you have to do to get full credit? First, you needed to separately show that the limits of the numerator and the denominator equal 0. You're not allowed to say equals 0 over 0. You get 1 point for confirming that the top equals 0 and the bottom equals 0. It was easy to find. F of 2 is just 1, so you get 6 minus 6, and you just plug in 2, you get 0. Then, the next step, you take the derivative of the top and bottom separately. We're just looking at slopes of tangents. We're just zooming in on things. Make sure you have the limit notation here. You get 1 point for the limit notation of the derivative of the top and the bottom, and then you get 1 point for finding the values. You can find the values. F prime of 2 is 0. F prime of 2 is 0, so you get -3 over -1. 3 points for the L'Hopital's rule. Hope we didn't drop 2 of the 3 because we forgot the limits. And then something that's meaty, the absolute min. I think this is probably worth 3. I think it could be worth 4. Now, I've done it different ways, so I'm going to show you the different ways. They all involve my sign analysis that I did at the beginning, only I'm going to start filling in some of the stuff on the top, like my function value at -2 is 3. I increase 1 to get to 4, decrease 3 to get to 1. I'm asked for an absolute min. Well, you could tell f is going to increase from 2 to 8. 8 can't be the min. Maybe you struggled finding these areas. Maybe you couldn't get that. Well, if you used this explanation, I don't think you would lose any points. I could say f has a min when f prime changes sign from negative to positive or an endpoint. From negative to positive, I get my candidate 2 and -2, my endpoint. I would think that my candidate is also 8, but watch what I'm going to do. I'm going to find f of -2. Again, you got to show how you get it. If you don't show how you get it, you're probably not getting points. You can't use this. This is only for your background knowledge. It's not to be used as explanation. So I say I got f of 2 and then I subtract the integral from -2 to 2. You could say f of 2 plus the integral from 2 to -2. But you see you got 3, add 1, you get 4, you subtract 3, you get to 1. So you get that, you got f of 2 and 1, and then look at what I did for f of 8. I said f of 8 cannot be the min. F prime is positive from 2 to 6. From 2 to 6, f prime is positive. That means f is increasing. Cool. And then I say f prime is greater than or equal to 0 from 6 to 8. I look at the entire interval, and yes, f prime of 6 is 0, so I have to somehow include that. But if I just say that f prime is positive from 2 to 6, and then it's greater than or equal to 0 from 6 to 8, we have to be increasing or flattened out from 2 to 8. F of 8 can't be the min. Boom, I win. I get all 4 points just by doing that. Stating that, giving the candidates. Now, let's say you are not comfortable excluding your candidates. Well, then you need to find the 6 minus pi, the 4 minus pi. You need to do all of the additions and the subtractions. And you're probably doing it when f prime equals 0 or an endpoint, which means you have 1, 2, 3, 4, 5 candidates. Endpoint -3, a local max 4, a local min 1, a neither 6 minus pi, but the derivative is 0, and an endpoint 11 minus 2 pi. You still get your winner, but you had to find the area underneath that half circle, which a lot of you are probably messing up on. So this would be the harder way to do it. You could have excluded that. Would have worked out. All right, question number 5 was the kind of curveball, where it's like, oh, we hadn't seen that many of these. We weren't really practicing these. But it's not that hard. It's just a bunch of derivative rules. Thought it was an easy question. Find h prime. It's just a chain. I'm going to use the chain rule. I'm going to plug in 7. Just making sure I work inside out. I need to do g of 7 times f prime of g of 7, or g of 7 and then f prime of g of 7, g prime of 7. I get the answer 12. Using your table to find all of your values, g of 7 is 0, g prime of 7 is 8, and then f prime of 0 is 3/2. So boom, 12. Probably worth 2 points, probably 1 for the derivative and 1 for the value. Little soft that they gave you f of g of x and not anything else, because everybody learns the chain rule with f and g of x, but that's okay. Part B was tricky. But I think they hooked you up a little bit. Using this dot, I think is very nice of them. I think in the past, they've probably said f of x squared, and then next to it was g of x. And people would have thought, oh, I got to use u substitution. Oh, I got to UDV if you're a BC student. Or it's just a chain. But they really hooked you up. They're like, yo, that's a product, that's a chain. You have to combine both the product rule, first time derivative of the first times the second plus the derivative of the second times the first, with your chain rule with an O and an I. So you get this very long derivative that I think is worth maybe 1, maybe 2 points. This is potentially worth 2 points where you're using the product rule and you're using the chain rule. Then using your table, you're finding all of the values that you need, plugging in 4. You do your calculation, you find that the second derivative is negative. The original question is k concave up or concave down. You need the sign of your second derivative to figure this out. So we get the sign of our second derivative is negative. K is concave down because the second derivative is negative. Maybe that's worth 1 point, honestly. Some use of the product rule, the value, and then concave down based on the sign of the second derivative. So that's 3. That brings us to what? This was 2, this is 3, so we're at 5. Find m of 2. I'm just plugging in 2 in for x. I get 8 times 5, which is 40. I have an integral from 0 to 2 of f prime. What do I tell my students? Whenever you can't plug an integral into a calculator, you got to take the antiderivative. Or you can see the area. All right, so I have to take the antiderivative. I need f of 2 minus f of 0. I need to find the displacement of f to find the area under f prime. F of 2 is 7, f of 0 is 10, so I get negative 3, 40 minus 3, 37. This is probably worth 2 points. Or 1 point, maybe. Maybe that's 1, maybe that's 1. I don't know. Maybe this is 1 and that's 1. Maybe it's only worth 1. Part D, thought this was easy. Is m increasing, decreasing, or neither at x equals 2? How do you figure out if something's increasing or decreasing? Look at the sign of its derivative. Is it positive? Is it negative? Well, m's increasing, m's decreasing. You look at m prime. The derivative of 5x cubed, 15x squared. The derivative of the accumulation function, the integral goes away. It just stays as f prime. If you said it's an integral of f double prime, I think you'd still be good. Because then you had f prime of x minus f prime of 0. No, it wouldn't work. Anyways, when you take a derivative of an integral, the accumulation function just goes away. Okay, so boom, that's gone. You probably get 1 point for this derivative, 1 point for plugging in 2, finding that that's a positive value. M is increasing because m prime is positive. So there's 9, maybe we had a 3-pointer with the crazy product / chain. Not that many tough parts in this one. Going to question 6. If you were in my class, you were ready for this. This is the exact same as question number 6 on our practice test. You should have been ready for this. Part A, show that the derivative's that. You should have been ready for the product rule. We practice this. Every time you take the derivative of y, you need a dy dx. I'm going to subtract the dy dx 6x, subtract it from both sides. Factor out the dy dx. Divide to solve. Divide the top and bottom by 3. Poof, I win. Probably worth 2 points. 1 point for this, 1 point for solving. So 1 point for our first step, where you're showing your knowledge of the product rule. 1 point for the solving. Part B, horizontal tangents. Horizontal tangents occur when your derivative is 0. Take your top, set it equal to 0. You get y is 0. You plug that into your original equation. For both B and C, we got to plug things into our original equation. We get 0 equals 2 plus 0. Well, my friends, that can't happen. So no point exists where y equals 0. So it does not exist. Boom. That's probably worth 2 points. 1 point for setting your top equal to 0 or referencing your derivative equaling 0. And then 1 point for saying no point exists on the original equation. Part C, though, a little trickier because when we have a vertical tangent is when the denominator equals 0, when our derivative is undefined. Now, what we have to do is solve for a variable. If you solved for y, this is a much trickier problem. If you solve for x, though, notice there's only one x in our original equation. That's going to be easier. Plugging in y squared over 2, when I take this bottom set equal to 0, plugging that in for x in the original equation, simplifying, solving that, piece of cake, we get y is 1. Once we get y is 1, you can either plug it into the original equation, get 6x equals 3, x is a half, or you plug into our derivative equation, which we already plugged into the original, x equals y squared over 2. You get 1/2. 1/2 comma 1 is the point. This is probably worth 2 or 3 points. 1 point, probably 1 point, probably 1 point, that's 3. And then part D, it's a related rates, but there's actually 2 ways to do it. It's a DDT. You got some information, don't panic. Either take the derivative of your equation with respect to t. Use the product rule. Every time you take the derivative of anything other than a t, you need a dx dt or dy dt, et cetera, et cetera. You got to use the product rule. 6 dx dt plus dy dt times 6x equals 3y squared dy dt. You use this information, you plug it in, you then solve. It's easy simplifications. You subtract 3 dy dt's from 12 dy dt's. You get 9 dy dt's equal -8. -8 ninths is dy dt. But there's another way, and this is really from like BC students, but some students in my AB class kind of figured it out. Does it make sense that dy dx would equal dy dt divided by dx dt? Yeah, if I like divided these two fractions together, wouldn't the dt's just cancel? Okay. Well, they gave me dx dt as 2/3. I could find dy dx by plugging in 1/2 -2 into the original equation, getting -4/3. Well, can't I just solve this equation for dy dt? -4/3 equals dy dt over 2/3. Multiply both sides by 2/3. You get the exact same answer. A completely different way, maybe a much easier way. It ends up being more of a parametric equation, like you may see in BC. If you didn't pick that up and you did it that way, it's fine, but congrats if you got it. Guys, overall, I thought this was probably one of the easiest free response tests I've seen over the last 10 years. Very straightforward. They were very helpful. They didn't want to trick people, putting dots, doing horizontal and vertical, not just the tough one. They do an easy one and a tough one. They did not do an accumulation function with another function inside of it. They did not shift any derivatives up or down with like an x plus f prime. So overall, or like 1 plus f prime, overall I thought this was very manageable. And I think my students should have been very well prepared. Whether or not they were, that's up to them. But, number 5, I can see us not being ready for. But everything else, straightforward, should have been able to handle, had seen it before. And maybe we don't pick up on all the tiny tricks like including this MDT, but still lots of points that we can earn. All right, that was more like 30 minutes, but whatever. Mr. Messer out. Love ya.